Okay, the final level of measurement is ratio scale. So a ratio scale data is like interval scale data, but it has an absolute 0 point, and ratios can be calculated. So when we talk about this absolute 0 point, that means there are no negative values that can occur for a random variable that is on a ratio scale. This ratios can be calculated is like a means to kind of test whether the scale you're dealing with can have negative values or not. Okay. But some other examples of ratio scale, I talked, you know, in interval scale about degrees Kelvin. But if we look at things like heart rate, okay, for those of you that are in the health discipline, right? You can't have a negative heart rate. You can have a heart rate that's really high, you know, um, you know, I don't even know what that would be, like 100 beats per minute or lesser or higher than that. Um, but if someone has a heart rate of 0 beats per minute, okay, they're not alive anymore. You can't have -10 beats per minute, right? You can only have 0 beats per minute. Same with blood pressure, right? They can have a low blood pressure, you know, but if they had 0 blood pressure, then that means they're not alive anymore. You can't have a negative blood pressure. Same is true for distance. You know, you could travel, from here to from wherever you live. You can travel from wherever you live to Disneyland, right? And that may be, like 400 miles in distance. But if you traveled from Disneyland back to where you live, that's not -400 miles. That's just 400 miles. So distance itself has a zero, right? You could travel 0 miles, but you can't travel -miles. You could only maybe change your direction, but the distance you travel is just going to be a positive number. The same with height, you know. Yeah, you could have a person that is, 0 feet tall, right? Um, right. But you can't have like a negative height, -5 feet tall. Same with weight or even age, right? You could have a human at age 0, but they can't have like a -2 or -5 years old, right? So these are some other examples of ratio scale. Um, let's see here. Now, I talked a little bit about, so I think just thinking about whether a random variable can have negative values is probably the quickest and easiest way to determine the difference between ratio scale and interval scale. Okay. But there's something called the ratio test. And the ratio test you apply, uh, and where you determine if doubling the numerical value actually doubles the property that the numerical value represents. So if doubling the numerical value does not equal doubling of the property, then that's an example of interval scale. If doubling the numerical value actually doubles the property, then that's a ratio scale. So what do we mean by that? Well, let me look at degrees Kelvin here. So if something was 293.15 degrees Kelvin, okay, if we were to take a thermocouple and measure the temperature of an object, and this is how hot it was. If we were to double that temperature to 586.3 degrees Kelvin, well, that represents 293.15 degrees Kelvin of heat energy. And we could definitely go 293.15 degrees Kelvin of heat energy in the other direction, and that would take us to 0 degrees Kelvin. So if we take 293.15 and double it, that doubling does represent a doubling of the heat energy. Okay, but by contrast, if we measured something to be 20 degrees Celsius and we double that temperature from 20 to 40, okay, that actually only represents 20 degrees Kelvin of heat energy increase. It doesn't really represent a doubling of the thermal energy because the thermal energy to get to 20 degrees centigrade is 293.15 degrees Kelvin of heat energy. And so if we were to actually double the heat energy that 20 degrees Celsius represents, we would have to double it way up here to get to whatever conversion. Let's see, 273. That would be 313, maybe 313 degrees centigrade roughly. So if we were to take 20 degrees centigrade and actually double the heat energy, it would be 313 degrees centigrade. But if we do it on the centigrade scale, taking 20 and doubling it to 40 doesn't truly represent a doubling of the amount of heat energy that's actually in an object that's been measured at this temperature scale, this interval scale. So this is interval and this is ratio. And this is this idea of doubling the quantity that that number represents. That's what we call the ratio test. And as a little bit of an aside, trying to introduce a little bit of science education into this statistics lesson here. Nothing in the universe can be colder than 0 degrees Kelvin. Okay, scientists call that absolute zero. And so, by the way, the following are condensation temperatures for various gases. So the condensation temperature is the temperature at which a gas becomes a liquid, right? Um, the temperature at which water turns from water vapor into a liquid is 100 degrees centigrade or 393.15 degrees Kelvin. Um, the temperature at which chlorine gas turns into a liquid is 239.18 degrees Kelvin. The temperature at which oxygen gas turns into a liquid is 90.19 degrees Kelvin. Liquid nitrogen is 77.35 degrees Kelvin. Helium that you fill balloons with, helium gas turns into a liquid at 4.22 degrees Kelvin. So that is really close to absolute zero. And it's so close to absolute zero, 0 degrees Kelvin, that liquid helium is used to measure magnetic materials in research in order to measure their magnetic properties. Because it turns out that thermal energy kind of messes with the magnetism of atoms. So you want to get things as cold as possible. And 0 degrees Kelvin is as cold as you can possibly get. Okay. So that's an example of the ratio scale. Let me know if you have any questions.